All right, folks, we're going to talk about derivatives of exponentials that aren't base E. And with that, we're going to learn about the lady called Ellen Bode. Okay. So this is going to be natural log of the base times the original times the derivative of the exponent. So when we take the derivative of an exponential, and this will work with base E as well. It's just the derivative or the natural log of the base is always going to be 1 because it's going to be natural log of E. So um, if you have to memorize one from 5.4 or 5.5, I guess memorize this one because this will work for all exponential content. So when we look at this, we're literally just going to kind of go through our 3-part checklist of taking the derivative of this function. So derivative here is going to be natural log of the base times the original times derivative of the exponent. Don't overthink it. If you need to, yeah, you can pull the 2 out in front, make that natural log of 9, all that good stuff. But right now, we're just working out the basics. Okay. Number 2, remember, we always start our derivative notation, right? Don't have part of the original, part of the derivative. Like if we're doing the derivative function, everything needs to be the derivative. So in this case, your 3 parts, natural log of the base times the original times the derivative of the exponent. This one, you got to be able to notice the product rule. Okay. So this is the product rule. So we're going to say y prime equals first, and then times the derivative of the second is the Ellen Bode. So natural log of the base times the original times derivative of the exponent. So that's first times derivative of the second plus second times derivative of the first. And I'm not too worried about taking care of the negative exponents. If you want to go ahead and do that, feel free to do that. Okay, this one is going to be the quotient rule. So when we take the derivative, we're looking at low to high. So the derivative of the high here is going to be our Ellen Bode scenario. So natural log of the base times the original times derivative of the exponent. So that's low to high minus high times derivative of the low. Derivative of the low is just 1 all over low squared. Okay. Here's same kind of setup. We got a product rule here. Okay. Looks like we got a little bit of a chain rule as well inside that product rule with an Ellen Bode component. So there's going to be G prime is equal to first. I just made an infinity sign. What was that all about? Times derivative of the second. So there's going to be derivative of the outside, leave the inside alone, and then times derivative of the inside. So first times derivative of second plus second times derivative of the first, and that's just going to be your natural log of 5, which is the natural log of the base, times the original, and then times derivative of the exponent, which is just negative 1/2. Okay. So however you want to rearrange that, that's up to you. All right. Now, if we have something that's log, the only difference with log versus natural log is instead of having a base of E, we have a base of 3 here. So we could look at this, and I haven't really talked to you about it, but I could rewrite this using change of base. So I'll do it with this one, and then I'll show you just how we can kind of work with it moving forward instead of doing this every single time. So if we want to use the change of base theorem, I'm just going to rewrite this as the natural log of x squared minus 3x all over the natural log of 3. Change of base just says if we're in this form, it's natural log of that over natural log of that. Okay. So if this is the case, this is the same as me saying 1 over natural log of 3 times natural log of x squared minus 3x. So we know how to take the derivative of this and this is just a scalar. So at the end of the day, it's really the same thing that we learned at 5.1, except you got to multiply by the scalar. So it's going to be 1 over natural log of 3 times u prime, which is 2x minus 3, all over u, which is x squared minus 3x. Okay. So I'm going to trust this scenario and just realize that if I'm in this form, if I'm in the form of y equals log base a of u, that and a is not equal to e. Even if it was equal to e, it would still work. It'd just be the natural log of e. Our derivative here is going to be 1 over natural log of a times u prime over u. Okay? So this is going to be g prime of t equals. Now, if I want, I can bring this 3 down in front first. I feel like I want to do that. Okay, so this is going to be 3 over natural log of 2 times 2t over t squared plus 7. Got some of my check marks. Okay, page 2. We're gonna, if we want to do this, we have a u prime, which would be a product rule with a chain rule in it. Not that big of a chain rule, but to me, I kind of want to rewrite this. Excuse me. So I'm going to rewrite this as, if I have a 1/2 there as a scalar, I could look at that too. This is the same as me saying log base 3 of x plus 1/2 log base 3 of x minus 1 minus log base 3 of 2. So if I take the derivative of that, this is just going to be 1 over natural log of 3 times 1 over x, because this is u prime over u, so 1 over x, plus 1/2 natural log of 3 times 1 over x minus 1. And then this actually derivative that is 0. So it's really just rewriting this. So somehow if you want to, figure out how to work that out, that's fine to simplify, but I'm not really worried about it, like I've said. So in this case, I'll rewrite it. Okay, this is a 1/3 power, so this is the same as me saying 1/3 log base 2 of 2x plus 1. Okay, and so if I want to take the derivative of that, this is going to be 1 over 3 natural log of 2, which you could write as 1 over natural log of 8 if you want, doesn't really matter, times 2 over 2x plus 1. Number 10 here, I'm going to rewrite. So this is going to be log base 10 of x squared minus 1 minus log base 10 of x. So if I take the derivative of that, this is going to be y prime equals 1 over natural log of 10 times 2x over x squared minus 1 minus 1 over natural log of 10 times 1 over x. Okay. Excuse me. And our last one here. Okay, this is actually going to have to be a quotient rule. There's really no way to simplify that or break it down any further. So g prime equals low times the derivative of the high, as the lights go out. So low times the derivative of the high. So this is going to be times 10 over natural log of 4 times 1 over t. So low to high minus high times the derivative of the low. So if you want, you can write it like this, all over low squared. And there's different ways to simplify this. I think my answer key from before, use the change of base theorem here and made it natural log of t over natural log of 4, and then somehow tried to combine these two and get the t's to simplify. To be honest with you, you got to be able to recognize what you need to do on the AP test for multiple choice. So just practice your simplifying if you really want to. Okay. But that is 5.5 derivatives of exponentials without base e. And next one will be integration of exponentials other than e. So stay tuned.